In example number 7, we are looking at the trigonometric functions and using them. And it's probably unrealistic of actually doing this, but here's where you can do it in real life. So we have fastball pitcher. She completes a clockwise rotation before releasing the ball. Suppose the pitcher's arm is at 28 inches long, okay, and the axis from which the pitcher's arm swings is at her shoulder height. So we can see that in the drawing here. So we basically have our y-axis and our x-axis here labeled, in here right here is our origin at the shoulder. And that her height up to her shoulder, so this distance from the ground up to her shoulder is 57 inches. And what's the height of the ball when the pitcher's arm is released? So in the end, we want to find out from here all the way to the ball, what's that height? And we know this from here to here is 57. Okay, so we just need to really find this distance right here, and then we can add 57 to that as our final answer. So our final answer of the height of the ball will equal 57 plus whatever this distance is. Okay, so we need to look at, here is our coordinates, right? Our x and our y, or x and our y. And so here we have this angle opening up at 138 degrees. So that is goes to right there. So we're in the second quadrant. So we're in quadrant 2. So in quadrant 2, we can find this reference angle right here, this reference angle right here, and then we can use sine, cosine, and tangent, because this one, if this is our reference angle, then across from here would be our opposite side, right, our y value, right? And once we find that y value, we can just add that to 57, and we have our answer of the height of the ball. Okay, so quadrant 2 would be 180 minus the angle that we're given, 138. So that means we're at 42. So 42 degrees is our reference angle. So I want to find this opposite side, and what is this distance given from here to her here, or arm length, right? 28 inches. So we're given this radius of 28, and we're trying to find this y value, right? So which trig function, sine of an angle, cosine of an angle, or tangent of an angle, gives us y over r? Well, tangent's y over x, cosine is x over r, so that leaves us with sine of an angle is y over r. So sine of our angle, which is now our reference angle, so I'm going to use my reference angle 42, is going to equal opposite, which is y, over our r, which we know is 28. So now I'm just solving this equation. Well, how do I get y by itself? I just multiply both sides by 28. And so now we have y is 28 times sine of 42. And then, so that I can just put in my calculator, make sure my calculator is in degrees. I might have to push mode and switch that to degrees. Let's make sure I'm in degrees. And then I type that in my calculator, and I get y is approximately 18.7. So then I just take that and I add it to my 57 for my height, 18.7. And I get a total of approximately 75.7 inches. And there's the height from the ground all the way up to the ball. Okay, so there you go.